Good morning, everyone. My name is Stephen. I'm a software engineer at Stripe. I hope you're all enjoying Dev Days. There's certainly been a lot of really interesting talks, and thank you for choosing to come to this one. We're going to talk about APIs, specifically the Stripe API. Now, the Stripe API, it's our main business, so we get really excited about it, and we will talk to anyone who will listen about it at great length. So before I get into that mode, I just want to try and take a little step back and explain why we think APIs are important. Today, we're in the middle of what's been called the API economy. It's much easier to scale to your first 100 million users than ever before. For companies founded after 2009, that was cut by almost 2/3, down to 25 months. It's also a lot easier to expand beyond your initial domestic market. Again, if you were founded after 2009, that was almost halved, down to 21 months. It's also far less expensive to start a company. Factors of 10. In 2000, it used to cost 4.4 million euros to launch a startup. In 2011, that was down to 4,400 euros. In fact, today with Stripe Atlas, you can do it for 500 euros. I think as well, if you're a student or a graduate, right now you can get it for $50. Don't do it right now, maybe after the talk. But if you're interested, check it out. Now, the rise of cloud and open source computing have had an undeniable impact, but we don't think you can ignore the impact of APIs. We think APIs are the fastest route to building a great product. Now, this is a pretty big claim. I'm going to walk you through it and hopefully bring you with me. API providers have a sole focus to give you the best product in their industry, and that's not something we can all build in-house. It might not even be necessarily something that we want to build in-house, especially if it's not our core competency. Take Stripe, for example. We process in over 140 currencies with credit cards and local payment methods through one easy-to-use API. Before, if you wanted payments with credit cards only, you would have had to build an integration probably per country. That's expensive and it takes time. And then you would have gotten to a market like Germany and you would have realized that only 22% of the online transactions are done with cards. So you would have had to build 3, 4, maybe even 5 integrations just to support 75% of your customers. You need to think about new trends, 3D Secure 2 and SCA. It stands for Strong Customer Authentication. It's new regulation coming to Europe soon. You don't want to have to build all this yourself. You just want to adopt an API, grow as fast as the entire industry, and give the best payment experience to your users that you can. So that when you successfully launch in Germany and you move on to the Netherlands, you can integrate Ideal with the click of a button. This is available today in more places than ever before, by the way. We just launched our betas in Lithuania, Greece, Estonia, Latvia, Poland, and Malaysia. If you're interested, you can go to stripe.com/global and request access. And we're growing faster now than ever before. This is my team, by the way. This is what I do. This is my day job. It's really exciting. I'm really proud of everything we've accomplished. But as you can see, there's lots of dark areas still on the map. We've got a lot of work to do. But it's exciting. Hopefully, maybe next year I can come back and we'll have a fully lit map. I'm digressing. We were talking about APIs and why we think they're so important. But why do we care about the people who use the APIs? The builders or the developers. Can I get a show of hands who's a developer here? Great. I say great because I'm much more comfortable making this statement in front of a room full of developers. But the reason that we care about developers so much is because developers have leverage. They have massive impact in industry. They are the people who write the software who can have a 10x, 20x, 100x impact on your company or even your industry. And that's why at Stripe we obsess about solving their challenges. And I think if you have an API, you should too. I have another question, and I have a theory on this, but I just want to check it out with you guys. How many hours a week do you think developers spend working on old code rather than new features? Some people have more empathy here than others. I'm one of them. Raise your hand if you think it's more than 5 hours a week. Okay. Keep them raised if you think it's more than 10 hours a week. Interesting. 15? Any takers? Okay, I feel your pain. Last year, Stripe partnered with Harris Poll to figure out the role of a developers in an organization. And we found that it was actually 17 hours a week on average. That's half the working week, just spending time keeping things running. I think these are US numbers, and my theory, by the way, was that European software is much better maintained, and going by the completely underrepresentative sample that we have here, that seems to hold out. But I'll reserve judgment for now. Stripe or your API should never ever add to these 17 hours. In fact, we should be working tirelessly towards fulfilling the promises of APIs and bringing that number down. Some people will say that developers are spending this time anyway, so it doesn't really matter. But part of what I want to get across in this talk is that even if developers are spending this time working on old code, you don't want them to work on your integration. Stripe has over 1 million businesses processing on its platform, and if we made a change that caused a developer to even spend 30 minutes working on code that was built with Stripe, that adds up. And that takes a lot of time, and we take that very seriously. That's why we put together these 8 principles on building amazing developer experiences and resilient, flexible APIs. The first is to align your business with your developers' needs. Now, I think a lot of these are written from a Stripe perspective if you're running your API as your business. I think if you have an internal API, or perhaps you work in a microservices type environment, I think a lot of these tips apply to you too. So instead of reading aligning your business with your developers' needs, think about aligning your team's goals with your developers' needs. I want you to think about some of the hard decisions you've had to make. Decisions about product, infrastructure, architecture, and I'll wager that a fair few of those were actually due to orthogonal motivations. We've seen in the recent past companies like Netflix, Spotify, Twitter, they've all had to make some really difficult decisions about their API. And that's because their businesses, in Twitter's case that was advertising, their business just became completely opposed to what their API was trying to do. So ask yourself some fundamental questions. If you get developers, will that be good for your business? And probably if you get a ton of users really quickly, you'll be likely to succeed in the short term. But that's not the sort of question you should be asking. You should be asking yourself, will your developers be more successful in the long term? I want to use a Stripe story to illustrate this. We're at Dev Days and there was a lot of developers, so I assume most people have heard of HTTP. It's the foundational protocol of the web. You've probably heard of 404. You might have heard a bad joke or pun in your time. 404 is a HTTP status code. It means not found. Something is missing on the internet. There's lots. The next one down is 403. It means forbidden. It usually means that you don't have permission, you don't have permission to do the thing that you were just trying to do. 402 is the next one down. That's not as popular. Can I get a show of hands from the developers if you've written an error handler for 402? Very good. I've worked in web software my entire career, and that included stints in MasterCard and now Stripe, and I've never coded for 402. It means payment required. And it's been reserved for future use from the very beginning of HTTP. And that's a shame. Beforehand, if you wanted payments, you went and you got the 466-page PayPal integration guide, or you fill out a form like this on a payment provider's website. This screenshot, by the way, is from 2008, not 1998. Stripe, like the original writers of HTTP, we thought that payments was a code problem rather than a finance problem. So we set about to write an API that abstracts complexity. So you can use the same API to process credit cards, Apple Pay, Android Pay, so forth or ideal. And if the API did that, then developers were going to succeed. And if developers succeeded, then Stripe was going to succeed. What's even great about Stripe's case is that business success meant that we could invest in our API, make it even better, and our developers were even more successful. But Stripe has evolved from simple payments. Today we want to be the economic infrastructure of the internet. Stripe Atlas gives entrepreneurs around the world fundamental tools and infrastructure to start and run an internet business. You get like a US company, you get an employer number from the IRS, you get a US bank account in Silicon Valley Bank. It's very different from our API, but it's going to be rare that our Atlas concerns will cross-cut our API concerns, because if developers succeed in starting their business and moving money on our infrastructure, then Stripe is going to succeed. This is a really heavy, weighty topic to start to talk with, and I probably shouldn't have done it, but I wanted to put it first so that we can just sort of stick it and leave it up there and think about it as we go through the rest of the tips. The rest of the tips are a lot more practical, and they're things that you can start doing for your developers today. The first is engagement. It's crucial to impress a developer in seconds, if not have them like integrating already. They might just be checking out your website in between unit test runs. So you need to give them a clear idea that you're going to solve their problems and you're going to do it really quickly. Stripe from the very beginning had code front and center. I'm really proud to say that we still do today. You can run it straight away, Previously, you ran it with curl. Today, you can do it with Node and RunKit right in the browser. Don't give developers any reason to leave. Don't make them fill out long registration forms or make them sign up or generate passwords. Just let them play with the API right away, and do it right there in the docs in front of them. It's surprising. It's delightful, and it just sets a tone for the entire integration. We found that this is actually key to adoption. And when it comes to adoption, supporting as many programming languages as you can really helps people onboard onto your platform. SDKs are great because they take away a lot of the concerns a developer has. They don't have to worry about specifics. They don't have to worry about object serialization. You can do error handling for them. You can do intelligent retries, like exponential backoff and jitter. You can do call optimization. So if somebody wants to load a payment object, you can automatically go and load the customer object for them, because it's more than likely that the developer is going to need that information later. The really great thing about SDKs, though, is that they let a developer integrate in ways that are idiomatic in their language. So if you can, offer SDKs or libraries to get people started faster. Choosing the language to support is a bit that's really tricky. Stack Overflow's most recent data shows that this is just more diverse than ever before, and it's going to be a lot of resources to support everything, so you need to choose carefully. Now, you can certainly use statistics like these to guide you. At Stripe, we use our developers, our API developers and our internal developers like me. We're actually really excited about React. So last year, we migrated our entire dashboard to React. It made supporting our Elements library in React just a really easy decision to make. In 2014, we saw a huge increase in the number of requests from Golang, and that made supporting Golang officially just a really easy choice. It's not always that easy, though. I know there's some .NET folks around. I've spoken to a few of you. For a long time, Stripe didn't have an official .NET library. We had a slow and steady user base in .NET, but it wasn't sort of enough to motivate us to build an official library. But we noticed that the community was starting to get into it. It was slowly growing. We saw some third-party libraries spring up. We eventually worked with the contributors to those libraries to bring them up to feature parity with our other SDKs. And then that became officially the supported .NET library for Stripe. But remember that you need to empower developers no matter what technology they're using. SDKs are great, but they're not an excuse for poor APIs. In fact, it's the opposite, because how you integrate in one language in an idiomatic way is not idiomatic in another language. So you need flexible APIs to be able to support that. You also need developers to be able to integrate directly. So your API will do a lot of really nice things for the user, and that might be great for the people who want to get started quickly. But you're always going to have a subset of developers who want to get a specific piece of data, and they're really obsessed with latency, and they want to get that just really quickly. So let them integrate directly via the API. You also need to support the long tail of developers for all the languages that you don't support, like the Rust or the Haskell fans. There's always like one or two. I'm looking for you. You're among friends. It's okay. Put the time into making like an elegant and cohesive API. At Stripe, we have API review every week, and that can be from reviewing a new set of endpoints to a simple JSON attribute change. API review consists of diverse engineers from across the company, people who work in different languages, work on different teams, and come from different backgrounds. We have internal documentation on our design principles and philosophy. This is really important. It's more important that it's written down, because we can share this globally. And this is actually what allows new engineers at Stripe to work on major APIs as their very first task. It's a big investment. It's a lot of time, but for a cohesive and elegant API, it's well worth it. Documentation. So documentation is really important to Stripe. And the thing that warms my heart most about Stripe is when I tell people that I work for Stripe, if they're developers, they always say, wow, you guys, your documentation is amazing. And it's great, it is, but I have a dark secret to share. I think if you actually print our documentation end to end, it's actually longer than the 466-page PayPal integration guide that I was making fun of before. But that's not the point, okay? We have documentation to let developers integrate in minutes, no matter what our API. If you don't have that, they might go somewhere else. In the decision-making process for an API provider, documentation is often critical, so make sure it's easy to access and delightful to use. We really obsess about our documentation. We try and build as many nice features for users as possible. You can search from anywhere. It's a single page web app, so it's really fast to load. We put demo keys right into the snippet, so you don't have to log in to use the examples. You can select your language, and then you can copy or click to copy the snippet into your language. We do lots of other nice things. So we have dark mode. I'm not really a dark mode fan. I prefer things to be nice and bright. But don't be afraid to do nice things like this for your developers, and don't be afraid to call it out. So someday documentations like this might be commonplace, and that'll be great. But for now, you can still be really proud of all the stuff that you do for your users. This is our API reference. Oh, we put the, you can't really see it, but when you're logged in, we put your actual keys into the snippet so you can get your data straight away. So this is my actual key. It's a test key, not a production key. You can't move any money with this if you're writing it down. It's not that I don't trust you, but please don't put your production keys in a slide in front of a room full of people. Thank you. We do this throughout, so the snippets are going to work right away. And we show it for as many languages as we support. We remember the language throughout the documentation as well. We store that in local storage, and we put a URL parameter in the address bar, so you can deep link somebody straight to a snippet for a particular language. The API reference, it's definitely the largest part of our documentation, and we find that it can be difficult to use, sort of unwieldy. One thing that we do that we found users actually find really helpful is we put their data straight into the documentation. So under the snippet, you will see the actual response that you see if you run that command with my data. It lets me make the links between the documentation and the fields and the backend data really, really easily. We try to make things work in front of the users. So if you're in Safari, you can do an Apple Pay transaction right there in the documentation. We find that really builds engagement. But this sort of turns things on its head a little bit. Brings us back to incentives. If you start with the developer and think about how they want to see the code in the documentation, then we think about how can we build that in Stripe.js, and how would we go about building the API to support that? It brings us back to doing what's best for the developer. And if you're doing what's best for the developer, you can be a little bit more sure that you're building a great product. Behind the scenes, our documentation code and our API code is stored in the same place. We have lots of different services at Stripe, but our API code is mostly in one repo. This means that we never publish out-of-date information to our users. Our CI build will fail if there's documentation missing. This is actually, this is really important. If you think about it, if you're reviewing code and it's a large change, it's actually easy enough to miss that the documentation isn't there, especially if it's a new process view, if this is something that you're just starting out. So if the documentation has to be there by a rule, you will see it and you will review it and you'll make sure it's excellent, just like the rest of your code. But the docs aren't the whole story. The snippets in your doc are going to work, hopefully, and that's the first conversation you'll have with your developer. The next conversation you'll have will be through error messages. Everything works until it doesn't. One thing at Stripe that we try to do is we try and give developers a way to solve the problem. We try and anticipate the common missteps. So if there's no authorization key on the request, we will embed the link to find the key in the error message, so the developer can just copy and paste and solve the problem straight away. Another thing we do is when a user tries to access their production data with their test key, we just let them know, or vice versa. We find that this actually saves minutes, if not hours. It creates a better experience. It creates what we like to think is a tactile experience, and I'm going to explain what I mean by tactile a little later on. So Stripe is almost completely self-serve, and it's mostly an automated system. We've got great docs, and we seem like the kind of developers you want to hang out with, sure, but that doesn't necessarily give you confidence in a rock-solid foundation. I think we have that reputation today, but not everybody does starting out. So when you offer support, you need to make clear what to do when something goes wrong. And when you do that, don't just bolt it onto the side. Make it core. Stripe has dedicated support team on IRC, Stack Overflow, and email. We offer public and private support. We try to respond in hours. Definitely don't block somebody for days. In some cases, that can be worse than not offering support on that channel at all. So for example, if you find yourself struggling to keep up with requests on Stack Overflow, maybe just think about not offering support on Stack Overflow and focus on making email the best support experience that you can. Transparency is really important. I think you need a certain level of maturity before you can do this correctly. you need monitoring capabilities, and you need good experience of your system. So you need to know how it goes wrong when it does go wrong. But that doesn't stop you being clear and transparent about outages and having a clear path for flagging issues when they do happen. Remember that you're a single point of failure for a lot of your developers. Some people will say that developers should have multiple API providers working in tandem, so when one stops working, you can switch over to the other one. But I think you'll find that's probably the rarer case. Backwards compatibility is one of my favorite topics. I could definitely talk about it for days. Shipping frequent updates and improvements to your API is great. Keep it up. But breaking something that a developer has built isn't as good. Do you remember the 17 hours we talked about? Avoid breaking changes. This is really easy to put on a slide or to say, but finding an elegant balance is really, really critical. But it's as difficult as it is critical. All upgrades to the Stripe API are versioned and non-breaking, so your integration will always continue to work. We do that by, when you make your first request, we lock the current version of the API to your account. When a potentially breaking change comes along, so for example, when we change a JSON attribute, we increment the version of the API. But because you're locked to the previous version, you continue to see the world the way that you did before, and your code keeps working. In the dashboard, we will show you a notification that there's been an API upgrade. You can see your current usage. And once you've reviewed the changes and you're sure you're okay, or you've had time to make the changes that you need to upgrade, you can choose to upgrade yourself or roll back if something goes wrong. I should mention that security is probably one of the things that we make exceptions here. So when we stop supporting an old version of TLS, that might become a breaking change. However, we know that payments are like the lifeblood of a business, so we take that very seriously and we actively work with users to make sure that they are able to upgrade their versions and we can all keep working in the most secure environment possible. Again, behind the scenes, how we do this is that we have a gate for each version. By upgrading, merchants can basically gate themselves in or out. And by separating request parsing and response building logic at the very top of our stack, we keep the rest of our code base relatively free from backwards compatibility concerns. The last tip on this slide is something that's about thinking bigger and challenging yourself. You might have built battle-tested systems. You might have uptime reporting. You can handle steady and bursty traffic. You're 100% stable, or you're 99.999% stable, but you're 100% ready to let your customers keep making payments. What else can you do? Well, Stripe thinks a lot about this, actually. And the way that we think about it is in terms of full stack tactile experiences. These are sort of strange words, so I'm going to explain what I mean by them. Developer experiences today are definitely full stack. With JavaScript, you can debug from server-side system calls all the way to the browser with Node and Chrome. If you work in Xcode, you can debug across multiple devices on all the old versions of iOS. In fact, you can debug across multiple devices at the same time. Xcode gets a lot of slack, but I think it actually does that really well. But what does that mean for an API platform like Stripe? We're a black box. And the way we like to think about it is how tactile is the relationship between Stripe and the developers. We want Stripe to be something that you can interact with, touch, observe, change, and get feedback. And that's how we build confidence in the platform, but at scale. We've talked about some of this stuff already. So consistency and attention to detail is critical. We've got well-designed error messages to improve the fluency of the conversation. Personalized documentation gives you an individual map of the APIs and how they all work together. And we work really hard on transparency and building trust. This is a good start, but we want to do more. So I want to share with you two things. One we do internally that we build for the builders that build Stripe as well. We do that internally, and we're starting to make it more available to the wider community. And one thing we do blatantly externally for our developers. The first thing is our developer dashboard. Last year, we completely revamped it, and we moved it to React. We wanted it to be a single pane of glass for developers. It was the right data and the right tools just to take intelligent action. We wanted it to be a conversation place. So when a developer has a question or something goes wrong, we wanted the developer dashboard to be like an illuminating or a reassuring conversation with the developer. It's just like talking with the experts. Some of the things we do in the dashboard is we highlight best practices right at the top. So here we've got a message to say that we found a null ID in one of your requests. This might indicate that there's an edge case in your payments flow that you might want to take a look at. We show you your API upgrade availability, and we show you the amount of requests you make at very different versions. You can choose to upgrade yourself and view the release notes, and again, if something goes wrong, you can roll back. Observability. So payments are very important for a company, and it's important to have observability on them. But if you're just starting out, you might not have that ability. And we don't want to force that on developers either, so we can offer that for them. I don't know how many of you are familiar with Postman. It's a really great tool for handcrafting HTTP requests. Stripe publishes a full open API specification, so you can import that into Postman. You can browse the whole API there, and you can create a debug request straight away. This saves a lot of time, and it really helps people get acquainted with the API. We also publish Stripe Mock, which is a simulated Stripe server that you can run on your laptop or on your CI environment, and you can write automated tests against a real Stripe server. So that's our developer dashboard, and the picture I'm trying to paint here is one of a conversation between a developer and the platform. The developer can see the APIs in the docs, they can test it straight away, they can try things or debug in Postman, and get informed error messages when things go wrong. We're trying to keep it conversational, and we're trying to build understanding with each message. And that's what we mean when we say tactile. The next thing I want to talk about is Sorbet. So Sorbet is something we built at Stripe. It's a type checker, and we're starting to make it more widely available to the Ruby community. Today, Stripe is made up of a lot of different languages. However, it began in Ruby, it's still a lot of Ruby, and it's probably going to be Ruby for quite some time. Now Ruby is typeless, and I've got mixed feelings about that. So I started my career in a really strongly typed language. I moved to Python, and then to Java, and to Ruby, and Scala, and back to Ruby. It's been kind of a journey. But it took me joining Stripe to realize that it doesn't necessarily need to be one or the other. You don't need to be typed or untyped. Today, we're improving reliability, we're reducing bugs, and we're providing the rock-solid platform that Stripe is known for, using the incremental type checker called Sorbet that we've been adding progressively to Stripe's Ruby code. I want to go through some simple examples of what you can do with Sorbet. But I actually find this really interesting, so if you want to talk about it afterwards, please do find me and just ask me questions. I'll talk about types for days. You might regret it, but I'll talk to you. The first thing you want to notice with Sorbet is uninitialized constant errors. So these are the bane of a Ruby developer's existence. Here I've defined a class called hello, and when I've tried to create a new instance of that class, I've made a typo. I left out an L. Ruby is going to punish me for it. To eventually get to this error, I have to run the Ruby code, so I have to start my Rails server and hit a web page. That's going to take a long time. Hopefully I've got unit tests, but in my unit test, I might be doing some database operations, and it might take some time. This might happen at the end of the test. So it's going to be some time between when I wrote the code and when I find out there's an error. With Sorbet, I can get that instantly, and I can import this into my IDE, so I can see it straight away as I type. We've done this for 100% of the files at Ruby. The Ruby files at Stripe. And you can just imagine the amount of time that this saves, and the amount of bugs that it just obliterates out of possibility. Undefined method errors, they're sort of similar. Here I've added a method to my class called greeting, but again I've tried to invoke it and I've made a mistake. With Sorbet, I see that straight away, and what's even better is if I add the typed annotation to my file, Sorbet will realize that hello.new is creating an instance of the hello class, and it will know that there's no method called greet on this class. We've done this for 80% of the Ruby files at Stripe, and it's had a huge impact. But it's more than just errors. Here we've got a pretty ambiguous method. It does its thing. It takes x as an input parameter. I don't know if x is a string or an integer, or can I pass a nil? Can I just leave it out at all? With Sorbet, I can annotate, and I can set the signature for the method. I can declare the types for the input parameters, and I can declare the return types. This is pretty simple, but you can do lots of really nice things, like declaring things with default values, optional values, nullable fields. Once I do this, Sorbet can tell me straight away what's okay and what's not. We've done this for 62% of the methods at Stripe, and this is something you can imagine. If you do this for a small piece of code, it helps that code, and it helps the code around it that calls that code. But then as you extend out, the benefits just get better and better radially. It's also fast, so we have millions of lines of code at Stripe, and Sorbet completes in seconds. All our builds are now statically typed, so we get this static type checking really, really quickly every time we try to submit code. We get better runtime error messages when things do get by the static checker. We also get better error messages, and we fail earlier. So that's Sorbet. Definitely, if you're interested, I can walk you through some really interesting features that it has. But for now, I'll try and summarize what we went through today. APIs are providing access to key pieces of infrastructure. They're the modern building blocks of modern businesses. The developer experience is paramount, and it's all about the details. We want the developer experience to be a conversation, but we want it more to be a two-way conversation. So watch what developers do with the tools that you build. Watch them surprise you, watch them inspire you, and learn from it. We've gone through 8 tips. I hope it gives you some ideas on how to make your API easier to access and easier to use. I hope I'll get to use them someday, and I hope I'll be delighted by the experience. But until then, thank you very much for listening, and enjoy the rest of Dev Days.